For horizontal asymptotes, the way you tell if there are horizontal asymptotes or where those horizontal asymptotes will be, you look at the degree. This BO is bigger on the bottom. And that second O right there is a 0. It means the horizontal asymptote, which we abbreviate HA, is equal to 0. Bigger on the bottom, bigger on the bottom is 0. BO and a 0. Y is equal to 0.
What is HA?
Horizontal asymptote. Bigger on the top. Is none. There is no horizontal asymptote. There will be an oblique if we can divide it, but none. BOTN is bottom, bigger on the top, there's none. The third one is bottom equals top. Now, this says C because it's easier to remember C, Betsy, but this actually means the leading coefficients. So the C stands for, it's going to be the leading coefficient of the numerator divided by the leading coefficient of the denominator. So bottom equals top is the coefficients, specifically the leading coefficient of the numerator divided by the leading coefficient of the denominator. That will be your horizontal asymptote.
I guess I'll be Iron Man.
Okay, so the way we're going to look at this, we're going to look at the degree of the numerator and the degree of the denominator, and we refer to those degrees with capital letters. Now, I don't know why this is being all yellow and why it's hard to read, but you have it in front of you. So if you look at the degree of this numerator, what degree is on that X in the numerator that we don't ever write? A 1. So the degree of the numerator is equal to 1. The degree of the denominator is what? 2. So the numerator is less than the denominator. So looking back at what you wrote on the front, bigger on the bottom, right? This is BO. So my horizontal asymptote. Now, the other thing I want to do is look at this in terms of limits. You can memorize the Bobo, Botan, and Betsy, or you can just learn to evaluate it using limits. So if we set x equal to infinity, and we substitute it into this problem, we get infinity minus 3 in the numerator, and infinity squared minus 5 times infinity, but which is still smaller than infinity squared, in the denominator. So as x gets larger and larger and larger, the denominator is getting larger than the numerator. What happens to a fraction when the denominator is getting larger?
It's improper. No. Oh, the numerator is bigger.
The numerator is getting bigger, but not nearly as fast as the denominator. So the denominator is getting larger faster than the numerator. So in any fraction, when the denominator is getting to be a larger and larger number, what is the value that it's getting close to? 0, right? Because we go from 1/2 to 1/4 to 1/8 to 1/16 to 1/32 to 1/64. All of those, the denominator is getting larger, but the fraction is getting smaller and smaller. So but it'll never be 0. It will never be 0. So by plugging in an infinity into this, we get infinity over infinity, infinity squared minus 5 times the infinity, but again, this is still getting larger. It's getting larger than the denominator. So we know a fraction where the denominator is getting larger than the numerator is approaching 0. Hence, my horizontal asymptote at y equals 0. Because that's what's happening to the function. So for the end behavior, as x approaches positive infinity, y is approaching 0. And on the left side, as x is approaching negative infinity, y is also approaching 0. Now, later on when you get to calculus, you'll have some notation that tells you if it's approaching from the left or from the top or the bottom. Just like with the vertical asymptote, if it's approaching from the left or the right. But for now, you just need to know it's approaching 0. So we use the synthetic division to find the oblique or slant. And it's all real numbers. So the degree of the numerator was equal to the degree of the denominator. So we use the leading coefficients, 4 over 2, to get the horizontal asymptote. So we get the horizontal asymptote here by using the leading coefficients. We set the denominator equal to 0 to get the vertical asymptote, which is x equals 1/2. As x approaches positive infinity, the function approaches 2. As x approaches negative infinity, the function approaches 2. And the range is from negative infinity to 2, union with 2 to positive infinity.